Welcome back. Now let us proceed. And line 32, we are doing we are finding out the list of the predictive variables. So what is the meaning of this? See, it is the full all column name, and this is response. Then if it's a function that takes this all column name minus response. Set if is the concept coming from the set theory. Set theory where we find union, intersection, and so on. Set is equivalent to set A minus set B. So if you see, I'm printing this one. It is having all the columns except the MPG column, that is our response. So because many algorithm needs all the independent features or something, you will see that we are going to use. That is why we have kept it separate. Okay. Now we are going to use the caret, and I hope you recollect the caret has been one of the very famous and very important library. And yes, now caret import has been done. Now we are going to test the collinearity. Again, I want to emphasize over here that there are a few concepts which we are going to learn over here. This is just for sake of your information. Many of these things will be done by the advanced algorithm on your own. You don't have to do anything. Only thing you should be aware of these features, these concepts. Okay, good. So in caret, there is that function that gives you the linear combo that try to give you that which are the features those are associated linearly, or basically that is collinear. And in line 36, that is the way we find it out. And so here in line 38 to 44, I'm running together. Then I'll show you that what it is doing. It has not printed anything. What it means that if there are no collinear features, okay, and if they would happen, it would have given that which collinear feature you should remove it. Okay, I'm just trying to print the lean underscore this. So if you see that it did not have anything. But generally, if you find any collinear features, it will give you this one. This one, it will have that list. And it will also give you that which one you should remove it. Okay. And this is just a guidance. You can definitely use other library or any other way to find it out. VIF is another thing. So it is similar to Collinearity, and VIF has been also used for some time. But I don't think it is used recently, but just for sake of your information, you should be aware of it. So let us see, and let me run it. Then I will explain you that what the VIF means all about. So I'm running line 47 to 51 in one go, and I'm printing this VIF value. Okay. So VIF feature, full form of VIF is a various inflation factor. So what it gives, that if any inflation factor that is more than 10, that factor or that feature should be removed. I have read the many research paper, few research papers say more than 5, some say more than 10, and something like that. But generally, what is meaning, what I have seen that people also remove more than 10. That is good enough. So what it is doing? First, it is trying to fit a linear model with this, and then it is taking the summary. Okay, and then it finds something that the origin Japanese column, this is not making much sense, so it is making it null. Okay, then fitting it again. And this time it is finding out that VIF. You see that this is the VIF that is coming from the car library and decreasing to. It means we are more interested in the maximum first. That is what you see over here. So how do people start with? Here it's saying engine displacement, that is having a lot of the it does not make much sense if you keep it. So people say it removes greater than 10, but does it mean that you're removing all these three? No, it happens like that. Whichever is the maximum, first to remove this and rerun this part again. And see that whether the inflation factor of each one comes down below 10. If this comes down below 10, it's fine. Else, rerun again. So one by one, keep on removing it. In this way, you can remove this high VIF factors. And again, I'm just saying that this is just for your knowing purpose, not necessarily that you should be doing it actually. Good. Okay. Now we are taking, since we have done some changes in the overheading, so that is why we are taking the list of vector variable once more. So let me write it. It's in line 54. We are again finding out the list of vector variables. Okay. And now let us do the variance analysis. So let me do this variant analysis first, and then I will show you that what this variance analysis is all about. Somehow here also did not get it. So what it is trying to do, if you have the data that is constant, like in case of employee ID, which is having unique for each of the row, so those data does not make sense. It means those are not varying at all. And something constant, any one column is fully constant. So that does not that is almost constant, so it does not have any sense. So any data that is unique or constant does not add to the regression or prediction at all. That does not give you the much value. And these are the fifth things: near zero variance. This is again coming from the carrot package, and it is giving around, these are the things you can read in the documentation. It is saying that around 95% variance must be there, and unique means that at least 5% difference must be there. Otherwise, if it is unique like employee ID, or if it is a variance, it means if it is a unique means each column is unique, then that does not add at all. There should be at least 5% variance. This is what it does it. That's all. And if there would have been anything, you would have seen it. But somehow we are working with data where nothing is there. That kind of dirty, that noise is not there. Nothing. Let me try to show you something. These are the few things. These are the few of the informations that gives. What it is trying to say, that weight is having around 88% unique. Zero variance false. It means that almost constant kind of nature. So if you see, none of these columns are almost in a constant. That is what you find. This is a false. And if you see, let me show you around origin European. So what it is saying, 0.51, that approximately half percentage is unique. Because if you recollect, these are the hot encoded data. So it is only 010101, and that is why you see around half of this one is saying unique, because it is having only 0101. Okay, and weight will have the more numbers. If you see that more weight is a numeric, so definitely there will be more number of unique. Okay, that is fine. But most important one was zero variance true. What it means, almost constant. That is what we should look for. Good. Anyway, we don't have that, so no problem. But if you have, you can remove it. So if you find that something is almost say 100% unique, like employee ID, it will be almost 99 to 100%. And if it is anything constant, that will become true automatically, this part. Okay. Good. That's all for this collinearity, VIF, finding out the variance, and so on. So that's all for this one. Thanks a lot for watching it. See you in the next one.